Here we have a question about rates. In such questions, you should expect that nothing too fancy is going on. All the rates can be expressed in a fraction measured in the right units, which in this case are molecules per minute, which means molecules divided by minutes. If we need to add rates, subtract rates, or compare rates, we'll do so in that format with those units. It turns out that the question is getting tricky with us by making ratios of ratios. The little p's are fractions that have the big P's in them. Glancing at the data statements, we can see that the data statements are in terms of the little p's, but we can apply the definition and substitute in the big P's, since that is what the question is really asking us about. So let's go do that, analyzing the statements separately first, as always. Statement 1 gives us P1 is less than P2. If we substitute in what the little p's stand for, we get the following expression. The question is whether this factoid presented by statement 1 means that P3 is the greatest of the big P's. Our hunch is no, since there are a number of variables to play with, which indicates that we are likely to come up with cases yielding different outcomes. Since all these rates are positive, we can multiply both sides and therefore obtain the following expression. P3 is less than P2 squared over P1. Here we can imagine cases. In one case, say P1 is 1 and P2 is a large number. Then P3 could be smaller than that expression there and still be larger than P2. However, in another case, P1 could be large, in which case the right side of the inequality is small, and P3 is smaller than that, so it's not the largest. We don't have sufficient information from this statement to answer the question that has been posed. Moving on to statement 2, here we can start in the same way, by substituting in the little p's. Then we get P2 over P3 is less than 1. This is useful in that it tells us that P3 is larger than P2. But we know nothing about P1, which could be big or small, so this statement also is insufficient. Combining the statements, we have a common element in the two inequalities, allowing us to chain them together. We can write the following expression. And since the leftmost term is smaller than another thing that is smaller than 1, the leftmost term is smaller than 1, so we can write the following. Now, if we know that P2 is larger than P1 and P3 is larger than P2 by statement 2, we have imported that fact into this combined case. That means that P3 is the largest, definitively. We have sufficient information to answer the question, so the correct answer is C.